Hello, welcome back. I have actually not started the game yet. Shame on me. Had all this time to get ready. Today, we'll be continuing the journey into sorting. Hopefully much more successful with it than we were last time. Yeah. So I did look at some solutions. I didn't dig too deep into code or look at them like laid out this way, so it was really hard to follow. I kind of have an idea of what they do. I'm not sure that I fully understand how to implement it without just like copying it, which is not what I'm interested in doing. I want to try and stick with this approach that I have, which doesn't work right now because I broke it. So the idea is kind of a bubble sort. So we'll push data into a node. It'll pull out the smallest it can find, push them in specific order, or it'll swap. Each pass it'll swap. And eventually, when we do a pass with no swaps, it will be sorted, and we can figure out how to output it. So that's basically going to be the approach that I go with. I'm thinking a data flow of, let's just kind of clear this out. You know what? Let's just start over. I'm thinking a data flow where we come in and we go into the stack node, and then this node will be the primary reader. It'll feed data here. This will be our greater than. So it's just kind of like reads input, waits. Don't know how to make it wait yet. Primary data handler. This will be the sorter. Pushes down. This is our is greater than, or our sort two numbers function kind of node. And then here, this is kind of a dual purpose data passing. Then we will output. And so these are all data passing up, data passing up, and data passing left. So the idea, read in, push in here, and then this reads in. We might have too much logic for this node. We'll figure out how to handle that. But this will read data. It'll push it to this node. This node will push here, get the greater value, push it in first, smaller value second. And then once this is done reading and receives a complete signal from here, it'll tell this to move. It'll move the data up here, and we'll kind of process it again. In that way, of course, it's going to be inverted. Now that I'm thinking about it, that could be very problematic. Because it's going to go into this node in the reverse order. Yeah, let's just try and get that working. So, just using these two nodes, I'm going to move one left, move two left, move three left, and then we'll move left up, move left up, move left up, and then we'll halt. And then this will just be like, we can just do our fancy little trick there. This will move down up, move down up, move down up. And so if we run that, if we push 1, 2, 3, 1, 2, 3, all right, we have 1, 2, 3, so 3 is at the top of the stack. When we move that, we move 3, 2, 1. So now 1 is the top of the stack. And if we move that back down, we're back in the order 1, 2, 3. Or if we come back over here, if we want the top of the stack to be the smallest value, then it will actually it actually won't be the smallest value. So I don't think this flow is going to work, because we'll push 1 and 2, and then they'll get swapped, and then 2 and 3 will get swapped, and we'll just be doing the same thing that we were doing before. Maybe we pull the top off every pass as we pass through here, and we just get rid of the top. Then we can resort the smallest value each pass. That may be it. Not even a sort, really. We're just kind of iteratively pulling off the smallest value and outputting it. It's going to be a terrible performance, but at this point I can't think of a better way to do it off the top of my head. So I think that's going to be the easiest way to get through this level, which is the goal, to try and get through this level. Just checking in on things. Okay, what do we got here? Let's read our input. So we'll pull an input, move up, left, into the accumulator, jump if 0, pause, and then we'll move the accumulator to the right. Yeah, we'll move the accumulator to the right. If we pause, we move 0. Actually, we don't want to move that. We want to move 0 to the right first. And then for pause here, we'll do move up, move down, nil. There we go. Okay. So we'll move the down value. So this will kind of signal back up here. And then this one will move up right into the accumulator. Jump of 0. This will start our signal. So this will be like move, I guess. And then move is just, we'll just tag that for now. If we're not moving, then we're going to move the accumulator to the left. Yeah. And then over here, we're kind of going to do what we did before. We're going to move. Let's implement greater than first. So we want to move right into the accumulator. We're going to save it so we have it in back. Then we're going to move right down. That's our second value. Then we're going to sub down. If it is less than 0, then that means that the second value is larger. So we'll do B, and then B here, and then the A flow. 1 second, folks. All right, kid aggro, gotta love it. Best part of being a parent. Always fun to see what he's up to. Okay, let's see. Jump less than 0, B. Yeah, okay, so if the second value, which is currently in our down position, is greater, we want to return it first. If not, then what's in, so we swap, we move accumulator right, because it'll be larger, and then we move down right. Otherwise, we move down right. Actually, we want to swap either way, but we can't do that. Okay, move down right, and then move the accumulator right. And this one will just move up into the accumulator, move the accumulator up, move the accumulator up, because we need to store that value for use. And then we need to access it multiple times. Let me do this real quick for my son. Okay. Back to it. Okay, so we have our greater than implemented. We have let's just make sure it works, right? If I move 1 left, and I move 2 left, move left down, move left down. I should have 2 and 1. So 1 went in first. 1, we're supposed to get the greater value back. Did I do this wrong? If down is greater, it's going to be less than 0 in the accumulator. And so we want to send the greater value first, right? How did that work? Okay, move 1. That gets saved. Then we move 2 down. We subtract. That's less than 0. We move 2 over. Wait a sec. What is... Oh. This one's still writing data. Son of a gun. Okay. That puts in 2, 1. Exactly, yeah. So that's right. And then if we just move like a 5 up here, then we should have 5, 2. Which we do. Okay. So that's great. So what we'll do is we always want one value in the accumulator, which is going to be our smallest. So we're going to assume that the first value we get from the right is our smallest value. And then we start our main loop here, where we move right into the accumulator. Jump if 0, done. We'll just tag that there. If we're not done, then we need to swap, move accumulator left, move before we swap, actually, we just want to move the accumulator left, swap, move accumulator left. So that'll get the stored value, the other value. We're going to get the greater value back first. So we're going to move left down. That'll be the greater value, and we're going to move left back into our accumulator where we save it. And actually, I'm going to move this save into our loop since we're going to need it. That'll save us an instruction line. Okay. If we're done, we need to signal somewhere. Actually, I think we can just wait here for like done. This done is just kind of waiting. So I think we can jump start. Maybe that's it. I did not name it start. Okay. So if we receive 0, we just go back to waiting because we're waiting on the data to get pushed out. If we get, let's say if we get a value that's less than 0 in the accumulator, we will like next. And so then our next will move, it doesn't matter what we move 0 up. And then that'll go back to start. And so this will be waiting on that signal to start pulling more input in. Cool. That's two parts. That's like half of the nodes down. Only the rest of the program to go. So let's see. What do we have? Does that push in? My headset died. That's fine. It works. It works without battery, just not as good. No active noise cancellation. Let's see. We're not pushing anything down. Why are we not pushing anything down? That pushed 0 in there. Because we got a 0. Right. We need to start the program somehow. So we need a signal to here to like start with the sequence. So we need to move up to the right, I guess. Yeah. Yeah. Next, okay. And then this will, before it pauses, it will move 0 down. And so this will, we'll call it a knit. Move left nil. Okay, so that should allow me to push in. What happened there? I don't have a jump. Jump L. That's L. Alright, so there's our read loop. We read in all the values. We got 15. We now move that down. That kick starts reading. That pushes 15 in. And that went back to a knit. Dadgummit. We got our loop here. Jump, loop. Yeah, okay. Read in our values. Okay, we push 15. Then we push 86. That moves 86 over. That gives us 86 back. And we store 15. And we are deadlocked. Why are we deadlocked? Let's get over here. Let's just put a node there, right? So run until that starts, okay. We get 15. We have 86. We push 86, we swap, we push 15. We move left down. Move left in the accumulator, and then we save. We don't have 0. We don't have next. We move the accumulator left. What is going on? This one needs to restart. Yep. Jump, start. Yep. Okay. Okay. So we step through here, get our 15, and then we get 15, oh, sorry, we got 86 back and 15. Now we passed in 27, and then we pass in 15 again. We do our math, 27 is greater, we push 27, then we have 15. Then we have 57. What happened? Did I not pass 0? We're at a deadlock. Move right into the accumulator. Oh yeah, because I did not code. Yeah, jump equals 0, move. Okay. So I think we need to start this one off. We need to move 0 down into there. We need to seed that. Because that's our terminator. That's how we know we're at the end of the list. How many values we've got. Alright. And so that's done. So we signal that we're done. We need to move negative. No, we're not done there. Move 0 left. Move 0 left. That'll trigger S, which is here, which is not actually what we want. We need more commands. We need more commands. So I need this 0 to be done somewhere else, like maybe here. Move 0 down. Not down. To the right. Left. To the left. So that'll kind of be our initialization there. That'll put the 0 in. That frees us up. So what I needed is got to push that last value in, like we're signaling in. So we're done here. And if we're done, we need to move accumulator down. We need to swap and move accumulator down. But we don't want to run either of those. Dang. What other piece can we eliminate here? Move up right. That's the kickstart. Move right into the accumulator. Save it. Move right into the accumulator. So I see that S is always followed by a save. I mean, S and this line are exactly the same. I'm trying to think of a way to maybe merge those two lines. But I need this save operation in between. So they're not identical, really. But then I see here where we move accumulator left and then we swap and we move accumulator left. So we move the right value. We need to get one value into back, basically, is what it is. Jump if 0 done. Jump less than 0 next. This next needs a jump to skip over this bit. What can we do? Move the accumulator left. Move right into the accumulator. Save it. Then we move into the accumulator. It's kind of annoying because if I can't make, like, if I don't have that value there, then this code has to change on where I'm pushing the values. So like the whole point of this piece is to set this node up into an expected state so that I can write a predictable set of code here where I move values. I do have to swap those values. Theoretically, I could avoid a swap. No, I can't avoid a swap. I can't avoid a swap. But I am going to receive a value again. Interesting. So I'm thinking if I move right into the accumulator, and then I start by writing my accumulator over, right? So then I just move. So the first thing I do actually is move accumulator left. So that's our saved value. Then the next thing I need to do is I've already moved one left, so I can get rid of you. So I pulled a value into the accumulator, and now I'm in the loop. I have my value active in the accumulator, so I move the accumulator left. Then I move right into the accumulator, which I don't need anymore. I don't need that value anymore because I've already moved it over here. Then I do my jumps. I no longer need this swap. Now I can just move the accumulator to the left. Then I move left down, and I move left into the accumulator. And then I don't need a swap at all. And that jumps the loop. Let's double check that. I'm pretty sure that'll work. All right, so we have 15 in the accumulator. We've already moved it in the accumulator. Now we move 15 over. Then we read the next value, 86. Then we push 86. We do the greater than. We move 86 down. Then we pull 15 into the accumulator, and we immediately move 15. Okay, so we've removed 2 lines. That's perfect. Next, okay, if we get 0 from this node, we are done working on that iteration. And if we're done with that iteration, we need to move the current accumulator value down, because that's the smallest value. So that needs to be the top. That's going to be what this guy, this node returns or outputs. Then what do? We move that down, and then we need to reset. So then we jump back to start, where we wait on the next run. Okay. And then if we are next, that means we're doing the next list. So we've done 67 to 15, then we do 68 to 59. So then we're on that list next. So what we do there is once that's done, we need to jump a init. And so we need an init. Okay. Okay, and we have an extra line. Cool. That cut that down. That was a bit of a thought process. Okay. So I think this is refined now. Now we need to work on this node. So we run it up here. We read from there. And then we push in 67. Then we tell it we're done. It moved 0 down. We don't want to move 0 down. That's right. Yeah. We do need a swap. Do we need a swap? Oh no. Oh no, did we lose? We lost 15, didn't we? Yeah, I think we lost 15. Yeah, we'll just get there. Okay. Maybe we didn't do a good job. Let's see, we've got 86, 27, all right, we've written 15, so we move 15 over. And then we move the accumulator down. Dang. So we're missing that value. We're missing that value. We need to save in a swap. Or we need to not write it immediately. What are we going to do? Now, because now 15's stuck over here, and we have no way to retrieve it. Nah. This isn't good. How do we get that 15 out of there? We don't have room for a swap. We don't have room for a bit. You know what? We could get rid of these two lines. As much as I don't prefer it, if we got rid of these two lines and we replaced it with a JRO accumulator, that doesn't work. That doesn't work. If we jump if 0 to I don't know, to n, I don't know what to call it. If we do our n here, n will tell us that we either jump into next, which would be if we read 2 values from the right node, then it can tell us to move down 1 or move down 2. What did that save us? That didn't save us anything. We deleted 2 lines, 2 jump lines, and we got 2 jump lines. Okay. So instead of jumping off input, we'll have to control where we jump. So we move that value into the accumulator. Oh, gosh. It needs to tell us what to do every step of the way. Like, it needs to tell us to loop, it needs to tell us to go next, and it needs to tell us to go down. That part is not a problem. That's one read. So we could do that with the JRO left. Now, right. If that gives us a 1, then we're going to move accumulator to the left. Then we're going to move right to the left. We're just going to move both of those values over. Then we're going to move the first value down. Oh, we're there. Okay. And then we can move the left value into the accumulator. So the greater value is going to go into the stack node, and then the smaller value. Yeah, okay, I unpaused. That one time I unmuted myself. I'm nervous about my OBS skills now. So we move left down, we move left in the accumulator. So if that's a 1, we're going to do all 4 of these operations, and then we're going to restart here, and we're going to wait on another command. If it gives us whatever is going to be this value to go next, we move 0 up, and we jump to the init. If it gives us a done, then we're going to move the accumulator down, which will be our small value this time, and then we jump back to S. That should work. We just need to change this. So if we are moving the value, the first thing we need to move to the left is going to be 1, because that's going to tell it what to do. Then we're going to write that. Then instead of moving 0 left, we're telling it that we're done. So that is going to be 1, 2, 3, 4, 5, 6, 7, 8. So we're going to move 8 left. And that's going to tell it to jump down to done. So that gives more control to this node, and we don't have to do as much conditional checking in this node. So that should get to the point where we are not working. Okay. Let's try that again. All right, we read in. Let's move All right, let's get here. Okay. Oop. Oh. We don't need that. We don't need that line. We don't need that line. That was the problem. Undefined label. Jump L. Yeah, okay. Run. Okay, so we move 1. That moves us down. Then we move... we don't have the accumulator. We don't have that value in the accumulator. We do need that first value in the accumulator. So it won't work. Technically, technically it won't work, but it will kind of work. It's a hack. It's a hack. Sorry about that. That is a hack. But it should work. That's our goal here. All right. Okay, we get here. We have 15 in the accumulator. Now we should be good to go. We move 86. We move 15. Okay, we did it. We got 15 in. Now we need to signal down here to start moving. So this needs to move 0 down. And this one needs to wait, move up nil. So that's waiting on that signal. Then we're going to move left into the accumulator. Jump if 0. Done. And yeah. We'll put it done here. Not sure what we'll do there yet. This will be our loop. So we need to end with a jump L before we forget it. We're going to move the accumulator to the right. Move it to the right. And then you are move left up. Move down up. Move down right. Actually, yeah, we'll JRO up from here. But let's just do this for a sec. Well, before we get there, because we need to tell this one that we're done. If we tell this one, if we tell it from here that we're done, then not all of the values will be written into the node yet, because they've got to go, they got a few cycles to get up there. So once we're done, actually the first thing we're going to do is we're going to move left down. And we'll move 1 into the accumulator and we'll save it. Move left down. Then we pull the second value off. If it's 0, we're done. If it's not, we move it to the right, swap, add 1, save. And that one's going to be when we're done. I think we could just do like move 1 into the accumulator and save it. Then down here we can swap jump if 0 next. If next, yeah, this one's gonna be tough. I may do a JRO. We'll see. But if next we want to, this is gonna determine if we start over, which will go up here. We'll go here. We'll go here to restart this one. Which should be, yeah, we'll just, oh yeah, we've got that JRO up here. I'm trying to think. I lost my train of thought. Okay, so we want to wait on that to get started. Then we move one in the accumulator. We don't need that anymore because we're not going to do... We're going to move off the top value. And then the next value should be 0. If it's 0, we're done. We do need move 0 into accumulator. That's going to be our initial. Then here, that'll be that. We'll save that into the accumulator so we can always get it swap. And then I guess we'll JRO the accumulator, which will determine where we go. So we've got next here. That's a 1. We need to signal, we'll just move 0 up. Let's move -1 up as a signal. We'll figure out what the actual numbers are. Otherwise, if there was more than one, value, we need to read again. So that'll just be, put that, get back up here to init. And then otherwise it'll be move, I guess -2 up. We'll figure out what the values are again. So the idea is that here we want to just wait again. Right, we're ready to configure the next. No, this one we assume we're done here. So that is jump once. If we've read more than one value off that's not 0, then we're going to write our second value, which is going to be 1, 2, 3. So 3. So we're going to move 3 down. And then once we get here, we can conditionally jump either next, where we move to the next list, or this, which will trigger, let's do the next iteration of this list, the next smallest value. Okay, so right, let's run that until we get here. So let's run that. Okay, so we move 1 into the accumulator. We move 15 out. Then we move 67. 67 goes up. Then we move 27 up. I did down right, not down left. Excuse me. At some point, we need to put a 0 back in this node. So I'm going to assume that we'll just always push a 0 first. So we'll go ahead and move 0 left, right. We always want to start with a 0 so we know where to stop that iteration. All right, so we push 0 up, we push 67 up. We've pushed 27 up, and then we push 86 up. And then we wait on more, because we're not jumping of 0. Son of a gun. Move left down. Wait, no, jump if 0. Wait, what happened? Sorry, I got confused here. Okay, we move 1 into the iterator. We move left down. Then we move 67. We jump L. We move left into the accumulator. We never wrote a 0 into this dadgum thing. So at the start of each pass, we need to move 0 down. Right? Like as soon as we start, then we read those values in. Wait, what just happened? What just happened? Why is there 0? Where's that 0 coming from? It's coming from up here. Yes, it is. Move 0 down. So this is our initialization. Okay, there we go. Now we've got the 0. Now we read the 0. And we swap. That jumps to 3. We push -2 up. And then that will know what to wait on up here. So we move that down, and then we JRO down. So that's going to tell us what to do next. Do we want to JRO down there? I don't think. Actually, no. No, we don't even need that, really. If we want to go back up to a knit. What is a knit? Move up nil. Move up nil. Yes, we want to go back to a knit. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we've read more values, we want to go to 11. No, this is fine. This is fine. But instead of moving up, we're going to move it to the right. And we're going to move it to the right. And then that's going to go here. And then that will go into the accumulator. If it's less than 0, we are going to signal. I'll call it sig. Otherwise, we will move accumulator up and jump L. And sig will do something. It'll end up moving accumulator to the left. So here we will JRO right. So that'll get the last number moving along up that list. Now, we signal down. We're at the move state, so we need to continue. If we need to continue, we want to move up to L, so that's 1, 2, 3, 4, 5, 6, 7. So if we want to continue, we want to go -7. And if we want to jump, if we want to restart, we need to go back to a knit, which is going to be -8 right now. -8, actually. Yeah, this will jump L. Oh, how do we put the code above it? We can put it right here. There we go. And that will jump a knit. So that will move What does it need to move here? We're here and this JRO, so it needs to move -1. Right, left. And then jump in it. It doesn't need to do that. So then that needs to move 1, 2, 3, 4. 4, if we're restarting, we need to go up 4. Okay, that's ugly, but it works. It works. Let's see. Where did that 0 come from? Where did that 0 come from? We saw we pushed a 0 down. So let's go through phase 1. We start reading again, 27, 67, 67. Wait, why is 0 in the accumulator? Move 1 left. Why is it moving 1 left? Move 1 left. Move 0 down. And then move the accumulator. Wait. What pushed the 0 into the top? We push 67, 27, 86. We push -7. That moves the accumulator left. Nothing pushed 0 into the top. So why doesn't it store that first value in the accumulator? It's going to be tough because that's the loop. If I go here, we run, and then we run again. Okay. Then I guess actually I want you to be the stop point. So we run again. Okay, we're here. Why is 0 in the accumulator? How did we end up there with 0 in the accumulator? Let's do this. We didn't stop it in time. Actually, yeah, we want this one. Run until that gets hit. Okay, so -7. Correct. -7 jumps us up. Not high enough. Whoa, 7, 8, 9. Okay, we need to go up 9. 9, not 7. Okay. That moves us up there. That puts 86 in. We wrote 86 over. We've got 27 now. Then we write 67. Then we write 27. We wrote 27 out. Okay, let's try running that now. Oh. Let's remove our debug statement now. So that put 15, 27, 67, 86, and now we're frozen. Why are we frozen? I guess let's do that. Run. So that should swap. That jumps 3. Okay. Okay, that's going to be 3. That's going to be 3. This time it's 0. Why is it 0? Because we didn't save it up here? Because we didn't save it up there. Mm-hmm. How can we do this? Because that's not saving. That's how we can do it. We can move this save here. Okay. Then we can run that. Then we can run that. Now we have 1. We jump 1. We move -4. We signal -4. That moves -1 left. That moves. Oh. Okay. Wait, that moves 0 up. -1. Where's the JRO? Oh, no. Yeah, okay. We don't want to go up 1. We want to go 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to go 9. We want to move 9 left. Okay. Yeah, when we get to that line. Oh, we still have this debug in. Let's remove this one. We're going to be pausing it a lot. We can actually speed up. Okay. Now we move 9 left. That jumps us down to move 0 up, which frees that up. Then we already have a 0 written in. Why do we have a 0? Where does that 0 come from? That 0 comes from there. So, before we move 9 left, we want to move up nil. We want to eat that 0. Yeah. We can still do that. Where are we paused? We're deadlocked. How did we get deadlocked all of a sudden? We changed the commands. We added a command here, and now we're not moving it high enough. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and -4 is 1, 2, 3, 4. We need to do 5. Yep. I mean, JRO is powerful, but it comes with some caveats like that. Okay, so now we move 9 left. That moves 0 up. Now we've got 1, 0 in the list. We read in the new. All right, and then we start And we got all of the wrong numbers somehow. Good gracious. Oh, right. Right. Oh, man. We need to push a 0 down. Because of course we do. We need to do more logic here. Because of course we do. Of course we do. I think if I move, like, these things just move over. So if I offload that to this node, then I can save up some room here. So what do I need to do? This needs to push 1 down. So when we're done, when we're moving to the next list, we are... I'm just going to copy all of this over here since this node doesn't really do anything. When we're done, we need to move 0 down, and then we go to init. Jump init. Okay. That part is still fine, I think, but what we need to do is we need to move accumulator left. Oh, that's not going to work. Well, that's fine. That's fine. Swap. Then we'll move accumulator left. We'll JRO left. Not left, right. We'll JRO to the right. Next is move 0 down. JMP init. Okay. Okay, so once we get 0, move left accumulator. If it's 0, we are done. Then we move that over there. And then it's going to tell us what to do. Okay. Yeah, that seems okay. And then over here, we're going to move left into the accumulator. I know this is fun. So much fun. How am I going to tell what to do? So I guess JRO right. No, because then it's going to have to send a command every time. Son of a gun. I need to send a negative value. So move left accumulator. If it's less than 0, signal. If it's not less than 0, we just move the accumulator up, and that'll be our loop, and we'll jump loop. If we need to signal, we'll negate the accumulator, and we'll JRO accumulator. And we have 2 cases where we are done and next. If we're done, we need to tell this node we're done. We already know we're done, so we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're going to move negative 13 left. And then we're going to jump L. If we're going to next, then we just move 1 left. And then we go back to L. Did I break everything? Probably I did. I did break everything. Yes. Because where are we at? Move the accumulator right. Okay, the accumulator is 3. And I need it to go 1. So where I write 3, I need 1. And where I write 1, I need 1, 2, 3. I need 3. I need to inverse those. Okay. Oh, we stopped there. But now we're moving 1. Ooh, that's not good. Oh. I need to push negative values. Negative values. Okay. We're pushing -1. It negates it. Jumps. Sends -13. We are deadlocked. Why are we deadlocked? Because we didn't push a negative value up. I forgot what we were pushing earlier. It's like -10. So when we want to continue, we want to tell this you're here. We want to tell this to continue. We need to jump back up to L. We need to jump back up to L, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So we also need to move -10 up, move -5 up. Okay. We did not offload all of the logic. That's why we had an issue. So now that's going to push -1. We negate that. A very hacky way. That gets us moving again. Okay, let's remove our debugs and let's see where we're at. So we get 15, we get 27, we get 67, we get 86, and we're frozen. Why are we frozen here? Let's just pause there. Okay, so we're passing -1. Okay. That's 67. This run should do 86. So that should be sending -3, which is what we want. That gets negated. Okay. We need to change our number from -1. So that's 1, 2, 3, 4. -4 now. Okay. -1. -1. -1. -4. So we send -4 over. That moves 1. That moves 0 down. That jumps back up to a nit. That moves -5. That moves 9 left. And we have restarted. Okay. I think we're okay. We froze immediately on a 0. Yeah. So I guess we need an initial bit here. Oh, jump. Move up. Accumulator. Jump of 0. End. I don't have the logic for that. Like I don't have the logic for that. Where do I put this logic in? So we get here, we have a 0 length list and nothing knows what to do with that. Nothing knows what to do with that. So when we get to a knit should be when we're starting off. Let's run that. What? Oh my gosh. Come on now. I don't. Okay. Okay. Run that. Run that. That's the next list. Next list. All right, everybody. Let's take a quick break. And we are back. Okay. Quick little break there. Trying to finish up this sort. We're stuck at a moment. We're going through here, each of these lists. Now we've got this 0 length list. We want to see, we immediately read a 0 in. We are done. We move 0 down, which moves 0 right, which immediately moves 0 up. Nope. Yeah, it moved it here. So I guess this needs to, oh no, that moves 0 down. All right, folks, I'm going to have to take a quick break again. And we're back. Case of a missing remote. Can't find the remote anywhere, though, so we'll do that later. Okay. Back where we were here. So if we get a 0 immediately, we need to tell something about it. This node is full, and it's the one that outputs. So I'm wondering if I just do this, if we just JRO up like that, and then when we signal it, we'll just normally signal it with a 1. And then we can move upright just like we do there, and then here, instead of completely discarding it, we'll JRO right. And then if we get a 0 on our first value, so I guess we want to move up into the accumulator, jump if 0, end. And then down here we have end. We'll go back up to the init. If we have end, we're going to move something down, which is going to move us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, and we'll move something down. So we're going to move 11 down here, Otherwise, when we pause, instead of moving 1 down, 0 down, we're going to move 1 down because that'll get here. We went a JRO left, and then that'll move us here. So that'll work like we normally do. And then here we're going to do 1. So normally we'll do 1. I already fixed that. Otherwise we do 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is that right? Yeah, it's off by 1. So 13, that'll move 0 down, and that will end us. So we'll move 13 down. And we got the wrong answer on almost every one of them. Goodness gracious. Goodness gracious. What did we do wrong here? So where's our first error? Okay. Our first error is at 86. We are losing some values. Let's go here. Okay. Okay. Where did 67 go? Did we just lose 67? I think we did. We lost 67 somewhere. Ooh, wait. We lost 67 because it was that move accumulator. Right. Yeah, because we enrolled that. So that should fix this. That should, if everything else works, that should have fixed the problem. That got our 67 back. Why are we not handling that? Why are we not handling that? Okay, so are we getting to end? That's what I want to know. Are we getting to end? We got to end. End moves 11 down, which jumps not far enough. It needs to jump 12. Okay. And then we did it. Holy Moses. That is way better cycle count than I could have dreamed of. Wow. 3,000. I think the optimized solution online is only like 2,000 something. Let me see if I can find it. It was the oh man. The TIS, it's in the, somebody made a GitHub document. They named it after some page in here, like it tells you to reference a document that doesn't actually exist from Zachtronics. So some of the instructions will refer you to, what are we looking at? Example program. Yeah. Tessellated Intelligence System Best Practices Patterns of Node Communication. So if we look that up, tessellated information patterns of node communications best practices. That should bring up the GitHub. Yep. And then, oh, that's not the one I want to share. Where are you at? There you are. Let's bring you over here. Let's make sure I share the right thing. Goodness gracious. Yeah. Boom. Is that working? That is not working. Probably because it's not a full screen application, is it? Let's go back to TIS 100. Let's see if we do, okay, there we go. Window capture. That'll just be, I'll just call you browser. It's fine. And, okay, that's huge. That's huge. Let's get you on here. There we go. Okay, that's good. That's good. And then I can just turn it off. Yeah. Okay, cool. Yeah. So if we look at, without looking into the solution, but like these algorithm parts, the sorter, 2,761 cycles, 9 nodes, and 77 instructions. And we are at, with 9 nodes, 86 instructions, so almost 10 more. But 3,000, I mean, only 400 cycles. I'm happy. I thought we were eating cycle counts. I was dead set that we were in the 100,000s. Oh, that was a rough one. Oh, man. Okay, one more to go, and it's probably not going to be an easy one. Read a length value from input. Okay, so 36. And read a color value from input. Draw a line of that length and color, wrapping when the edge of the image is reached. Okay. Yeah. Okay. I'm pretty happy with my JROs now. So we've got a length, so let's move the length, move up to the right. We'll move the length over there, and we'll move the color down. And so we'll move color down. We'll move that to the right, and so we have the color. If I recall correctly, drawing images, it's going to be X, Y, and X being our column, and Y being our row. X, Y, where are we at? Control Z. No, wait, what am I looking at? Visualization, yeah. Yep. The coordinate system starts at 0, 0. The module can be specified starting X, Y, one color value, and then we terminate with a -1 when we have completed that color value. So if we move 0, that's going to be our X. This will be our X node. So we'll move 0 into accumulator. And then we'll loop that. We'll move the accumulator down. And then we'll JRO down. That'll tell us what to do next. Here, this will be our Y. So we move 0 into accumulator. We probably won't revisit that because the Y is going to change throughout. And then we will move up, down, move accumulator down. Then we need to do some math. We need to add 1, save, sub 18. That's how many? No, we're 36 characters wide, right? 36 characters. Oh, no, that's the large. We're 30 characters wide. So we're going to sub 30. And then we can jump if less than 0. If it's less than 0, then we need to increment. Otherwise, we just jump L. Or we don't. We move -1 up. Otherwise, we move 1 up. So, and then here, when we increment, we'll move 0 into accumulator. No. We'll reset. We'll jump back to start. This will actually I need to read in the count too. Yeah, I need to read the count in. I don't want the count to go that way. Move up, down, move up, down. Yeah, this is just going to be our coordinates. This is just going to feed us x's, and this is going to feed us y's, and then when this increments, so we'll move 1 up, and we'll jump s. And then here, when we increment, we will move what are we moving? We add 1, jump L. Yeah. Okay, and then we're gonna move left into accumulator. So this is starting a line, and that's our count. Then for our count, we'll do our draw loop. While we're drawing, just got a notification, nothing important. While we're drawing, we will, we need to set a color. So I guess we'll save. We only need the color once, right? Yeah, we feed in a start X and a start Y. Oh, I think yeah. I remember why I wanted to push the move up left. Yeah, okay. I think I have an idea. I want to make this dumber. So I need to do an XY and then a color. And so this will be the color. And this will be the XY. But I need to give it a command. So I guess what we'll do is we'll move up, down, that's our XY. And then we'll move left, down, that's our color. And then for our loop, we will JRO up, so it'll tell us what to do. And then over here, we move 0 in the accumulator, we save, we move left into the accumulator. That's our line count. So we want to swap. Right. And then we want to, for our loop, we want to swap, move the accumulator down. That's our current X. Swap, sub 1, jump if 0, increment. And then we increment X here. Which is swap, add 1, and then jump L. Otherwise, we jump L. Right? So we start on the line count. We swap and we do X. Here we've swapped, we're at X. And so we need to swap again. That'll move us up there. We got a swap to get back to line count. So that should handle our X's. That'll, for every line, it'll push a line count down. It'll push an X down. And then down here, this one actually doesn't need to tell anything. This will handle X changes. Will it handle X changes? No, it won't. No, it won't. We need to restart. When it's 0, we need to go back to start. But we don't want to put 0 in. When we reset, we want to make sure yeah. When we reset, we do just want to go back to start. That should be fine. And we're ignoring the push down. It's the one that needs to tell us that we need to. So JRO down. Wait, yeah, move up, down. Whoop. So I move the accumulator down every loop. That's saying this is the current X. And then down here, I'm saying we're going to start by setting the column to 0. And then we'll probably never need to go back there. Move up, down. So that's move the X down. Move the current column down. We don't always want to move up, down, do we? Yeah, this is a tough one. So if it's not 0, then we just continue. So, yeah. I think I'm on the right track. I just need to think about it a little bit more. So we've got an X and a Y node, and they're in parallel right now, which is what we kind of need because we need the Y node to tell the X node what's up. So the X node is going to write X down, and then the Y node, but is it going to write X down? It needs to tell the Y node what to do. The Y node either needs to increment or it needs to write X down. Which means that the X node either needs to increment and move on. Tell the Y node we're good and move on. Or if it needs an X. So I think we're going to defer. So here, instead of moving the accumulator down, we are going to ask the Y node what to do. We're going to ask the Y node what to do. The Y node no, because we need to tell it when we need to signal a new X and Y value. So I think x is our least concerning value, right? Like we know what x needs to be. Every time we write a number out, we're basically going to increment our x. We're not using the accumulator here, so I think this can be our x. We don't need an x node. We do need a node that receives the count and then instructs what to do here. We do need to track y. I'm wondering if I can move the y tracking over here. That may be the best bet. Move y over here and just get it out of band. So count, so this will just be move up, down. So you're tracking x. So x, we're just going to start at 0 in the accumulator, and that'll be fine. So when we get y, when we need to get y, which we'll send increments over for every read. So we're going to every loop move left nil. It doesn't matter what we get. We're going to do the same thing. We're going to add 1. We're going to move that accumulator. We're going to add 1. Actually, it does matter. We always want to add 1 every loop. But we need to know if we need to get the current y value and then do the loop, or if we need to. So I think if we move that in the accumulator, nope, that's going to erase it. All right, so when we loop, let's push -1. That way the first loop is going to be a 0. So when we loop, we get our current y value. We don't need to, oh, we do need to save it. We sub 30 because that'll let us know if we need to increment x. We don't do that yet. Yeah, I think I'm going to say get down here. We'll just move accumulator left, jump L. And so this will just be JRO right. And so we'll push and we'll read depending on what we need from it. So we need x, so we move accumulator down, that's our x. We move uh, 1, 2, 3, 4, 5, 6, 7, 8, 9. We move 9 right, and then we move right down. That's our y. We move left down. That's our color. Then we kind of start our loop where we go for each up. So we save, move up accumulator, jump if 0, done with that line. I don't know where that's going to go yet. If we're not done with that line, we're going to move 1 down. And we're going to move 1 left, which we don't need to do anything. We don't need to move one up. We just need to jump back up to start. Because we're starting the next line. Well, I do need to know. I do need to know if we've hit that point. Because I'm going to expect a signal. So that's going to be, I move one left, and then I'm going to JRO left. Wait. Move it right. JRO right. That's going to tell me if I need to increment or not. So I'll add swap. Add one. Save. And then if I'm done, I need to move -1 down. And then I start over. So this is increment. I need to increment by moving one left. If I don't jump to increment, I need to move 1, 2, 3, 4, 5, -5, right? So if we step through, we don't do anything with the count. We need to move left accumulator, and then we will move 1 down, move jump if 0, done, move 0 down, otherwise jump L, done. If we move 0 down, this needs to move up into the accumulator. If it's 0, we're done. Otherwise, we do these. Okay, so what do? We did left and not right. We need to go right with it. That sends 36 over there. That sends 2 down. We've written, I don't know what we've written out. I haven't been paying attention. We're stuck on moving 9 right. And it's JROing right, left. It's not moving anything right, it's moving left, okay. That gets down there. That gives me the current Y. We put the color. We move 1. Why did we start all the way over? Why are we incrementing? Jump equal to 0. 30 minus 30. Actually, it'll be 29. Will be the 30th character. Why did we change colors? Why did we change colors? We wrote 0 down, and then we wrote 2 down. Why did we write 2 down? This one needs to be left. No, right. Hang on. Move the accumulator down. That's the X. Then we move 9 right, which says give me Y. That reads 0. We write 0 down. Then we write 2 down, which is our color. Then we save. We move up into the accumulator. Yeah. We could send commands that way. I think I'm going to do that. Move up into the accumulator. We don't even need that because then we don't have to swap all the time. If we just JRO up, that'll tell us move 1 down. Move 1. What does it read? 3. Oh, we write the color down. We have to write the color value down. That is right. We write the color value down. So this needs to store the color value.
Okay, media will play.
Yeah. And then we will JRO left, right. Move accumulator left. Do we want that? I don't think so. Move up, down. Move up, right. So I was thinking about having this be kind of like that, where we just store a number. But actually, if we're not going to be using the accumulator for testing, then we can keep the accumulator as X and the other value is the current color. So if we move left into the accumulator, what am I doing here? Move left into the accumulator, move left down, yeah, into the accumulator, and then L will start with move accumulator down. And we save that. So we move the accumulator down. We don't want to save that. We want to swap, JRO up, move accumulator, move 1 right. Okay, let's do JRO up. Okay, that'll move the accumulator down. And that'll move 1 right. And then we get right to tell us what to do. We don't want save. We probably need to swap back. And then jump L, probably. And then over here we need to double check our counts, right. If we want to increment, we want to go one down. Wait, -5 left is 1, 2, 3. -3 now. and then increment is still 1. Okay, and then up here, we'll normally move 1 down. Yep, move 1 down. And then here, we'll move 1, 2, 3, 4, 5, 6, 7, 8 down. Okay. That's outputting to wait a minute. I just had an epiphany in a sense. No. That's not doing anything. That's just going to keep writing forever. Yeah, what are we doing here? Okay, if we're not done, sub 1. I need the sub 1 there. If we're not done, jump L. Done. Print. This should print for a while. Whoa. What just happened? First we write 36. We're not getting 36. So that writes 1 down. We wrote 1 character. Okay. So 36 should get us all the way across. What are these numbers? Holy great, man. Wow. What are those numbers? Where are we going wrong there? Okay. That reads that number. That pushes a 1 right, adds 1 to our character count. We save it. We sub 29. If it's 0, we increment. We move 3 left. And then we never swap. Swap. Yeah. Okay, now we've got right, because 10. That puts us back there. All right, that keeps us going as we get closer and closer to that edge. We never output the new X. We need to output a new color. Yeah. That's why I don't think color. I think color, if we move color move up left over here. Move left, move left accumulator. That's our color node. Now we need a JRO up, and that's our loop, and then we jump loop. So now you will tell us to move accumulator down, which will be JRO we'll move one down, move accumulate down, and then we restart. Or we're done, which is -1. Nope, we gotta do done here. We want to move 8 down, and we want to, yeah, that's it. So you're just 1, 2, 3, 4 now. So you're telling this one what to do, this one will tell this one what to do, and this one will store the color. That means we just need to track X, right? Move the accumulator down. That's our X value. So this will be line. Move 10 right, which says give me Y. That gives me Y. And then we don't care about that. JRO up. So 1 down will move up down. We'll move 1 right. JRO right. That'll tell me if I need to increment or continue. And then when we're done, we're going to move -1 down, and we'll go back up and start the next line. Okay, let me make sure that these left values are correct. If we're not incrementing, we need to go -3, which is 1, 2, 3. Yeah, that's still good. And if we are incrementing, we just go 1. That's still good. And then obviously 1, 2, 3, 4, 5, 6, 7, 8. Ooh, we don't need all these swaps, actually. We just had 1. So 1, 2, 3, 4, 5, 6. 6 down. Okay. We're immediately stuck. We're immediately stuck because we moved to the left and not the right. Okay. Okay, so that's drawing our value. We're nearing the end. Okay. We've restarted. We've incremented X. When we increment X, so it does need to be 30. When we increment X, we need to start over here. We need to go back to line 2. Yeah. It's basically, it needs to say, no, we're just going to move in that. We don't need to jump. Which means we need to 1, 2, 3, 4, 5. 5. We need to move 5. That would probably still work because I know that it'll wrap. But just for clarity's sake, we're going to pull that down. Pause. Okay, we're at 29. We're on character 30. We add 1, we increment, we push -1 down. Then we write 1x. We get our current y, which happens to be 0. And we push that over. Then we just read in, why are we not? What's going on? We pushed -1 down. That should have terminated the signal. Yeah, we pushed -1 down. I don't get it. Run until we get there. Okay, next step. That moves 0 into the accumulator and then it waits. We move -1 down. We move 1 down. We get y. We move y down. Then that tells us to move 2 down. Something is wrong. Something is wrong. Why is it wrong? If I move 0 down, move 0 down, move 2 down, move 2 down, move -1 down, move 5 down, move 4 down, move 3 down, move 3 down, move -1 down. That should draw, yeah. That should draw on those lines. So what's the deal here? If we move -1 down, what's the problem? We got 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Because this is x and this is y. That's why. That is why. Move 10 right. Then move right down and move the accumulator down. That's why. I had my axes backwards. Okay. Now that moves -1 down. Then we get the current x value. And then we write the new y value. And then we write the current color. And then we change the color, which just happens to be the same color. And we run through that, and then we're back here. Okay. Let's remove this debug. I feel pretty confident. I still want to run it on slow, but I think we're going to make it. I need to pull up my stream manager here. Oh, hey. Hey, sorry. Hello. How are you doing? Watching the stream. Hey, we got a white color. It looks like it's right. All right, we're printing some white. What? We've moved on to a different color. We're printing gray again. We're back to printing color number 2. Moving on some more. We're back to white. So far, so good. If this goes, yeah, white. And then we should switch over to a dark color. All right. And we're good. And we're good. And we're good. And we did it. Whoops. I didn't do that. I didn't do that. Did it just reboot? Okay. That's interesting. we're up here to the simple sandbox. So what changed? Yeah, we're 6,000. We're not bad on cycle count. Node count's okay. Instruction count's kind of a little high, but that's fine. Did that change anything? I don't think that changed anything. I think we did it, folks. That's TIS 100. Yeah. Don't know what to do with these kind of free-form user segments. These could be pretty fun. Can I write something? If I run it, oh, there we go. I input a number, and it'll do a thing. I don't know what what exactly to do with this. Again, if anybody wants to suggest ideas, we could do that. Otherwise, we'll probably move on to something else. Another Zachtronics game. Another one that I've started before, but I would like to finish and happily restart is Exapunks, which is another programming game by Zachtronics, but I think I want to kind of flip-flop here between like programming and puzzle solving. So one of them that I have started but only gotten like pretty early in is not a Zachtronics game, but it's by the Zachtronics team, and that is I'm going to close out of that there. Let's see, it's Kaizen, a factory story. So we can play that. That's not really programming with code, but it is programming. So, yeah, I think we'll pick up there next week, and we'll do something that's not programming for a little bit. And when we finish that one, Exapunks. Definitely going to do Exapunks. That one was a lot of fun. I think I made it halfway through probably, but yeah, that Exapunks is really exciting. All right, folks. That's it for Thursday. Have a good rest of the week, and I will see you next week. Cheers.